Okay, let's finish up with slide 52 here on smooth muscle, contraction, relaxation. Remember, calcium is the trigger, but it comes from extracellular fluid and binds to calmodulin in the cell, not to troponin like in skeletal muscle. Calmodulin activates an enzyme called myosin light chain kinase, which activates the myosin ATPase. Then myosin binds to actin and conducts a power stroke. And in this case, ATP has a direct role in the power stroke. Thick filaments pull on thin filaments pull on dense bodies and pull them closer. And remember, the cell contracts in a spiral manner. Here's a drawing, a depiction of what's happening. Calcium coming from the outside, binding to calmodulin. Calcium complex. This activates myosin light chain kinase, which activates the myosin head and hydrolyzes ATP, and the cross bridges form and a power stroke happens. And so myosin ATP is hydrolyzed ATP, providing energy for the power stroke. So, like I said, this is really different than skeletal muscle, where ATP does not have anything to do with the power stroke. It recocks the myosin cross bridge. But in smooth muscle, it has a direct effect. It causes the power stroke and causes the filaments to slide by one another. Now, smooth muscle relaxes by another enzyme called myosin light chain phosphatase. Kinases put phosphates onto molecules, and that usually activates them. So, myosin light chain kinase, and then phosphatase takes them off. Enzymes and calcium channels are really slow. So there's long latency time in smooth muscle, much slower contraction in skeletal muscle, and usually less tension generation. But smooth muscle is different and it has what's called a latch bridge mechanism. So I don't know quite how that works, but allows the myosin to be attached to the actin for long periods of time without using more ATP and not getting fatigued. Remember, your GI tract, your blood vessels are always partially contracted your entire life. And opposed to skeletal muscle, which doesn't exhibit tetanus, um, smooth muscle does. And it's very resistant to fatigue, and that's misspelled there. Sorry about that. Most ATP is made aerobically. It doesn't use much anaerobic mechanisms, but the ATP requirements are quite small for smooth muscle. And like I said, these qualities allow it to be contracted for long periods of time to maintain smooth muscle tone in your GI tract and in your blood vessels, mostly. Okay, slide 55, response to stretch. Some ion channel is mechanically gated and stretch leads to peristalsis in the digestive system, which moves food along. Um, there's a stretch relaxation response. This happens in the bladder. Brief contraction and resistance to stretch, but then it relaxes. It allows urinary bladder to stretch and hold urine without expelling it immediately. And remember, there's no length tension relationship in smooth muscles. This is quite different from skeletal muscle also. The force of contraction independent to the degree of stretch. Doesn't matter how much it stretch, it's still going to generate the same amount of tension. So response to stretch, smooth muscle. Plasticity, smooth muscle adjusts its tension to the degree of stretch. I mean, there's no Z discs. You can't have too much or too little overlap of fibers because there are no sarcomeres. And there's no H zones where there are no myosin cross bridges. There's myosin cross bridges throughout the entire thick filament. And that's it. We're all done with the muscle video.